Okay, in this video here, we're going to have a review on example 8 in the notes where we have the question solve inequality modulus x plus 4 over 1 minus x greater equals to 2. If you refer to the previous solutions, you find out that it is happen to be quite long and tedious. So in this video here, we're going to recommend or produce for you another method which is shorter, but make sure you realize the precautions in this case here. So this is the shortcut with precautions to take notes. And before we apply the shortcuts to solve these questions here, there is some properties of modulus that we need to recall in order to help us to solve the question here, which is first, we have the property in such that if let's say I have modulus fraction a over b, this is actually equivalent to, or we can rewrite it in the form of modulus a over modulus b. Next, some properties that is very basic, which is, let's say I have the case of modulus of some number. This result is always greater or equal to 0. And in the case of I want to study, if let's say I'm talking about the denominator is a modulus. So this denominator modulus, I should have it in the situation that just greater than 0. Where it's trying to tell that the denominator here is always positive. This is the criteria that we need to alert and take care in order to apply the shortcut here. So now let us begin our solution by copying the original inequalities from the questions. So firstly, we will from here define into two cases and solve. By the time we already have the arrangement is such that we have modulus on the left hand side, and furthermore this is a positive modulus, and then the rest of the terms on the right hand side we will define and solve, and the solution is long and tedious. In this shortcut solution, first of all, I would like to apply these properties here. And we're going to break this modulus into the part of modulus x plus 4 over modulus 1 minus x greater equals to 2. Next, what I would like to do now is that I would like to get rid of this denominator here by multiplying modulus 1 minus x on both sides of the inequalities. And in here, if we recall back on the previous work that we do, usually for inequality, we don't simply multiply both sides with the denominator terms. Because this is the reason is because previously what we have for the denominator is some x term where we don't know if it will contribute to the result of positive or negative for the denominator. So that's why we are not allowed to multiply them on both sides. As multiplication in inequality, it may affect the change of sign here. However, in this question here, the shortcut, we are going to do this, and we can do this because first, we are very sure that this modulus here is always happen to be positive. As the properties that I mentioned just now, modulus of something is always greater equal to 0, and it will be greater than 0 like this case here if it's happened to be at the denominator. So if it's always positive, therefore the inequality side won't have any effect on the directions. So we are all right to do this multiplication. And of course, with an extra condition, because just like this form here, it is not proper. And what is the conditions that we need to note is that there is a condition that you need to realize in the first and second case, which is the denominator 1 minus x shall never ever equal to 0. So in other words, your x shall not equals to 1. So this is the condition that we need to take notes and we need to write it down. then only we can say that these two or even these three inequalities, they're equivalent to each other. So once again, I want to explain that from the fraction form, it's understood, maybe we say that it's understood that we know that the denominator cannot be zero. So this condition is being known. But by the time is in this form here, without writing this condition out, we will find out that, or we will just declare that this thing here ever exists, and of course it won't be equivalent with the previous two. So this condition is something very important, the one that I highlighted in purple. And later in our solution, step by step, I would like to have this condition being written over and over again to remind ourselves that these conditions needed to be there to take notes. Go on. Now refer to these third line inequalities. We find out that we have the case of modulus on both sides, and the two modulus is different with different functions. And the techniques that recommend to solve in this case here is that we're going to have the solution that we square both sides. We square both sides. So as a result, we square both sides. I will have x plus 4 square greater equal to 2 square 1 minus x square. And once again, write down the conditions. Then now we expand our result. We have x squared plus 8x plus 16 greater equals to 4 multiply 1 minus 2x plus x squared. And once again, the condition x shall never ever equals to 1. I want it to be stated there, so that each of the line are equivalent to each other. Further, we find out that at this line here, it seems that we have the framework of quadratic inequalities. But let us further simplify to verify, is it really we have a quadratic? So the right hand side, we expand. I have 4 minus 8x plus 4x squared. The left hand side still maintain the same. And once again, the condition x shall not equals to 1. Now, let us try to simplify the quadratic inequalities. Refer to the square term. Refer to the x term. Refer to the constant. And I would like to group everything to the left. I find out that I have the result of minus 3x squared plus 16x plus 12 greater equals 0. And once again, the condition x shall not equals to 1. Reach up to here, we have a quadratic inequalities. As I'm going to solve using the old school way, where I'm going to make use of graphical methods to solve it. And in order to achieve that, I will continue with factorization. And since nowadays, you all like to use calculator to consider the factorization's result, so I would like you to take note of some precautions that before you refer to your calculator for factorization results, that in your quadratic expressions, please take notes on the x squared parts here. I want you to always remember we want to make it become positive coefficient, and then we want to simplify common factors. And these two things here, actually we can do it at once lah. But anyway, you can see what are the situation we have here. So first, we see that we have negative coefficient for x squared. Then for common factors, 3, 16, 12, we don't have common factor. So we just need to deal with changing it into positive coefficient for x squared. So the next line, I would like to multiply everything with -1, and this will give me the result. The quadratic will turn to be 3x squared minus 16x minus 12, 0. And the inequality sign, is be aware, you multiply negative, so it will change direction, turn to become less than equal. And once again, we state the condition x shall not equals to 1. Then continue. We would like to refer the left-hand side to factorizations. I have 3x, x. By factorization, I suppose I have 3x plus 2, x minus 6. Once again, state the condition x shall not equals to 1. Then now, I'm going to solve by graphical method and watch out for my solution here using graphical method. I will consider solving this part here. I highlighted in red as usual. So I have a case of smiling face curve. The x-intercept here is being contributed by each of these linear factors when the time is 0, where x plus 2 is equal to 0 when x equals to minus 2 over 3. X minus 6 is equal to 0 when the time x is equal to 6. Refer to those two figures here. We're going to arrange it accordingly into the intersections of the graph and also the horizontal axis. Go on. Before we go on further to decide the answer by looking at the graph, whether it's the graph above the horizontal axis or below the horizontal axis, I would like to have an extra step here to emphasize that the case that we would like to have the situation x not equals to 1 in our calculations here. So refer to the number line here. We detect where is the location of x equals to 1, and I found out that it should be somewhere in between here. So this, I make a remark. I would like to have x never ever equals to 1 in the number line as a remark. Then now, let us see for the situation that we would like to have less than 0 for the solution for inequalities. Where is the location of graph we're going to refer? So if you're referring to this part here I highlighted in yellow, this part of the graph is less than 0. Equal to 0 if you refer to this contact point of the x-intercept. And then now, for this part I highlighted in yellow of the graph, it involves of what x value? It will be involved of the x value as I highlighted in blue on the diagram here. From minus 2 over 3 all the way until 6. So by right, based on the blue highlighted part, it shall be corresponding from negative 2 over 3 include all the way until 6. Don't forget the extra conditions here. We need to exclude x equals to 1. So if I check in number line by right, the drawing will happen in this way here. There's a hole between minus 2 over 3 and 6. And this hole here is located for the value of 1. So as a result, from the diagrams, we are able to obtain our answer turn out to become, if I would like to write the form of interval notation, it will be start from negative 2 over 3 until 1, open bracket for 1 because we exclude 1, union from 1 until 6. So this is the answer if it happens to be interval notation. So this is in interval notation. And if you're interested to know what is the answer in set notation, so it will be a curly bracket with x dot dot. The interval will be from negative 2 over 3 included. So we have less than equal x until 1. Or we can just refer to the set notation I have on top there as reference to get answer. The union, instead of writing union, we write the word or. Then we have 1 less than x less than equals x. And once again, the remark here, the word or here, comma, union are not allowed to be written inside the set notation. Of course, you don't write and because the case is not and here also. So therefore, this is the solution for the example. If you try to use the shortcut method, important to take notes the precaution step that I highlighted here. Please always write it down to remind yourself. If you don't write it down, somehow you will happen to forget to determine in your final answer most of the time. So that's it lah for the video here.